Good afternoon and welcome again to the group exhibit for hydrogen fuel cells and batteries. Please, everyone on the outside, please feel free to come in, sit down, have a seat, and enjoy a complimentary beverage. My name is Michael Sinclair and I'll be your moderator for the next discussion. I'd like to remind you that audience questions are welcome anytime. Put up your hand and I'll be glad to bring the microphone to your table. Here to talk about supply chain participation in the move to electrification for fuel cell and battery components. We have the Global Director of Business Development for the Power Technologies Group from the Dana Corporation. Please join me in welcoming Mr. Brian Cheadle to the stage.
Thanks, Michael.
Brian, thank you so much for joining us. If you wouldn't mind, could you please start by introducing Dana Corporation, your products, and the markets that you serve?
Sure. Dana Corporation is, or Dana Incorporated actually, is a large automotive parts manufacturing company. It's American-owned but operates globally. We develop new products through our technical centers, which are regionally based. For instance, I'm located in our Canadian center in Oakville.
Just down the road from where I live, actually.
Ah, excellent. And my colleagues here at our Dana booth are from our German technical center. We develop these products based on where we have local competency and where we have a product mandate accordingly. Dana is a very large company. We operate in 26 countries, 26,000 employees. Been in business for a long time in the automotive world, so we have lots of experience in developing and manufacturing new products. So we're here at the Hanover this year to promote our advanced products in electrification. These are fuel cell components and battery cooling and power electronics type products.
And traditionally you're known for producing what kinds of products?
Our traditional products would be under the hood engine components, like head gaskets and cam covers, various kinds of heat exchangers. Outside of our own business unit, products like axles and drive shafts.
So Dana is known for developing products typically for internal combustion engines. So why is Dana here? Tell us again a little bit more about why you're at a fuel cells conference.
So this is our 14th consecutive year here at the Hanover Fair. We have looked at the whole field of electrification as opportunities to grow our business. We are in the middle of the electrification technology transformation, and that transformation creates a huge demand for new kinds of products that didn't exist before. So our hope is to apply our competencies and leverage those to create products needed by our customers, who are typically system integrators or vehicle manufacturers, things like that.
So you mentioned you have existing competencies that you feel like you can leverage for EVs. Tell us about what those competencies are and how they apply to this somewhat different industry.
Okay, so for example, one of our products that we are engaged in is bipolar plates for fuel cell engines. The metal bipolar plates that we have developed are a competency leverage from our traditional head gasket products. Head gaskets and bipolar plates are similar in that they're layers of thin foil materials with integrated seals. The bipolar plates have different requirements, in some ways more sophisticated requirements, but we're able to leverage that past competency in head gaskets, design and manufacture, so that we end up being able to develop improved bipolar plates faster and with deeper technology than if we tried to do it from scratch.
So what would you say, is there anything unique about the products and services that you're able to offer into the EV space?
We have, as an experienced manufacturing company, we have skills in the design of the product, design for manufacturability, to get the products to perform optimally, and prototype testing through to scalable manufacturing. Besides bipolar plates, the other products that we have on our booth and are actively developing are things like thermal management for fuel cell lift trucks, power electronics that are used in DC to AC converters in electric vehicles, whether they be battery, hybrid, or fuel cell vehicles.
Do you guys do anything for non-transportation applications for fuel cells?
Yes, some of our fuel cell engine applications are in non-automotive. These would typically be small stationary or sometimes vehicles that are outside the normal mainstream automotive, like buses and things like that.
So the talk title is Supply Chain Participation in the Move to Electrification, Fuel Cell and Battery Components. What advice can Dana offer from a supply chain perspective for EV system technology companies?
Okay, so the usual challenge for our fuel cell system integrator customers is finding suppliers who can produce the new products that they need with required performance, quality, cost, and ability to scale them up from low to high volume. And customers can spend a lot of time searching for suppliers with those abilities. Typically, these new products are not off the shelf. They've got to be developed. On the supplier side, our challenge typically is that the customer's application requirements are often still evolving. The timing and volume commitments are unclear, and so it's a struggle sometimes to establish a business case. The only way around that, and the most effective way, is for customers and we as a supplier to engage in a collaborative basis. If we have open communications about what the technical requirements are, the business plan, the modules of investment that are acceptable, then we can work together effectively to develop solutions both for today, and we can also help our customers develop a cost trajectory for what the product could cost or could look like from a manufacturing point of view at different threshold levels of investment and volume.
With such uncertainty in the market for potential volume, how does Dana, for example, know that this is the right business to be in?
We rely a lot on customer feedback. If we have customers who have good business plans, we kind of piece together a market picture from that and gain confidence in our customers' growth in those markets. We also, we are a stakeholder as well as all of you here in terms of this electrification transformation, so we rely on other ways of getting a feel for the industry. We participate in different fuel cell associations. I think our next speaker is from the Canadian Hydrogen Fuel Cell Association. We're a member of that. We participate in the US DOE workshops. We participate in the Baden-Württemberg E-Mobility Council. Those are ways for us to participate in the market and gain confidence in it.
So in terms of the process, you mentioned, component, developers, people developing EV technology should come and approach suppliers like yourself early in the process. How early, and then tell us about the process of going through the development process.
In a way, as early as possible, but really, once there is a targeted application with some ability to define the volume scale up and a reasonable definition of the functional requirements. That's when it's important to start talking with suppliers.
So can you tell us some about the ongoing projects that you have in fuel cells?
Sure. One of the projects that we actually have at our booth that's quite relevant to the topic of supplier networking is our work on the AutoStat Core Consortium. This is a European-funded program that tries to network OEMs, suppliers, and academic institutes to overcome some of the normal barriers of information and technology sharing. So in this AutoStat Core project, we have OEM partners like BMW and Volkswagen. We have suppliers such as ourselves, Freudenberg, Greenerity, the MEA supplier. and academic institutes like the ZSW and Fraunhofer Institutes. So this has been quite a successful project. We've been able to demonstrate by actually building a stack how we can achieve state-of-the-art performance and make real improvements in the performance. We've managed to meet or exceed most of the targets in power density, decrease the size of the stack, the weight of the stack, and so on.
Were there any unique design challenges for this project?
I don't. I would say they're typical design challenges. They're working with the OEM to agree on a specification of what is required, looking at the packaging constraints as well as the functional performance requirements, and then negotiating with the other suppliers how to optimize the trade-offs in the different components to achieve the best outcome, including establishing cost models to project the cost of the final products.
And what would you say has gone really well in this project so far?
What's really gone well is the networking with the other suppliers and the achievements that we've gained by this process of collaboration. It's what we like to see in working with our customers, the same level of collaboration. We can get the same kind of benefits.
You mentioned that you've been working towards achieving better communication between the different suppliers. What did you put in place in order to achieve that?
I'm sorry, what?
What kind of systems did you put in place in order to better communicate with the different stakeholders in the project?
A combination of face-to-face meetings and conference calls and sort of the normal business mechanics of communication. But once you've got a shared goal or a shared objective, it kind of pulls in the collaboration quite naturally.
Just a reminder to the audience, if there's any questions, I'd be happy to take them. So EV components probably represent a fairly small portion of Dana's current sales. How would you forecast the expected growth of the industry for the next number of years?
We are seeing very strong growth in the battery and hybrid vehicles. They're the leading edge of electrification. There's actually quite strong shifts in the development programs of most of our automotive customers in that direction. Fuel cell vehicles are lagging a little behind that, but there's similar strength of development activities there. And then we have the non-automotive markets that are already engaging in fuel cell applications. In some cases, we can take, we like this leverage principle. In some cases, we can take a product in fuel cells. For instance, we make bipolar plates, either metal or molded composite ones. The molded composite ones can be used for fuel cell engines. They can also be used in flow batteries, which are part of the energy storage part of the whole energy system. So there's multiple growth opportunities from these different products.
And I guess from your perspective, what will be the main drivers of cost reduction that'll lead to widespread adoption of these technologies?
Cost reduction is what we're used to doing in our traditional business. Once you can define what the product requirements are and your volume and investment thresholds, then you can design a process to take out cost. And we're pretty optimistic that we can reach the expected targets.
So scale.
Yep.
Scale is something that you do well.
That's correct.
So, So for more information, I'd like to welcome everybody to stop by and visit Dana's booth. It's just over here at B71. Please join me in thanking Mr. Brian Cheadle for joining me in this conversation.
Thank you.
Michael. That was great. So up next in the public forum will be a conversation with the Vice Chairman of the Canadian Hydrogen Fuel Cell Association and the CEO of